And today we're going to learn more about the high rate communication system from Diego Serna. He is one of the CATO officers here in the International Space Station Flight Control Room. Diego, we'll get you to start by telling me what a CATO is. What parts of the station's system are you responsible for?
Yes, we basically manage and troubleshoot all the onboard ISS communication systems. Basically, these systems are the audio and video system, which basically distribute audio and video throughout the space station. We also manage the S-band system, which is our primary form of communication with the crew. We use the two space-to-ground voice loops, as well as command and telemetry through that system. We do also manage the ultra-high frequency system, which is used for a command link between the station and the crew during a spacewalk. And the last subsystem we carry is the Ku-band subsystem, which is basically the one that we use to downlink all the video and all the payload experimental data, which basically is a subsystem that will get the greater bulk of the updates with this new high rate communication systems
Okay,
updates.
so yeah, and that's an awful lot of different systems, but the high rate communication system upgrade is in just a portion of that, right? What is it going to add?
Well, basically, like I said, the Ku-band system will be the primary system that gets upgraded. But for the most part, as the upgrades go, we will basically be adding two additional space-to-ground voice, so we can talk to the crew. We currently have two. We'll go to four. We will add two more video channels to downlink all the video that we have. Currently, we have four. We'll go to up to six. We will also have the capability to downlink up to 64 different experiments at one time. Currently, we only can do 8. Uh,
Wow.
One of the major changes, though, is the fact that we will double our downlink rates from 150 megabits per second to 300 megabits per second. So things will be downloaded a lot quicker. Our uplink file capability will go from 6 megabits per second to up to 25 megabits per second.
So it's not just the additional channels, but it's also a pretty big increase in the speed that everything's going to be communicating.
And that is correct. We will definitely do all this downlinking, uplinking rather quicker than we do today.
Is this a result of technology or hardware that wasn't available when the station was built?
Well, partly it is. I mean, most of the HRCS technology is new, but we do have to make this technology work with the onboard um, technology, if you want to say that. But
Hmm.
for example, we will still be floating video, but we will be using the latest video encoders so that we can get um, better quality at a lower bandwidth rate. If you want to talk about technology that is brand new to the space station, we could have currently all our video recording and all our payload experiment data has to happen in tapes. Well, when the HRCS goes up there, we will be able to do all this storage, all this recording using um, the mass memory recording. So basically, we'll use solid state.
We're looking right now at the live video that's coming down as the crew members are laying cable, as I said. Can you give us a sense? I know you're not looking at it, but what cables are they laying? Is this to transmit it or to connect up different modules?
Well, this is a starting point to what we're going to uh, basically set up the cables for the arrival of the HRCS. We call it the KUCOM unit. Basically, the ORU that has all 8 functionalities into one. And so we're laying up that work right now to put the cables in there so that we'll be ready for it for the KUCOM unit to once it gets on board to be installed.
With the addition of extra channels, how do you anticipate that they are used? What's the design for how these extra routes of communication will be used?
Well, we'll try to keep our ops concepts rather simple at the very beginning. But for example, the audio channels will be set as a alternate voice channels to the primary current ones that we have on S-band. We will try to use them as a, if we have overflow of conversations, we can always go to them, do private medicals on those. Things that we are not critical right now will be used as an alternate.
is this system then going to be in use throughout the space station, or will it be primarily in the U.S. segment?
Well, the HRCS is going to interface with our current onboard equipment, so the benefits will go through the whole space station, and including benefits that will carry on through different ground stations or international partners.
So this extra communication and the high rate will be not just with Houston, but with all of the control centers.
That's affirmative. Specifically, our international partners are folks in Marshall, which run most of the payload data. They will be able to uh, perform more experiments now that we have clear out this bottleneck that we had for 8 channels up to 64.
That's a part that I really wasn't familiar with, and that's quite an expansion. Have they been asking for that extra capability?
Well, I think
They've been
we've
crying for it?
I think we've known for a while now that there is a limit in channels that we currently have. We've basically been somewhat at a max for a while now, so I think the HRCS comes at a time that it's going to be at a perfect time where we can now expand and start doing more experiments as the station evolves into that type of space station.
And a station with more labs and more crew members that are doing more science.
That's correct.
Is all of the hardware on board just waiting to be installed now?
Well, there's several units that are critical in the path of the HRCS activation. Currently, we have automatic payload switch, which is a ORU unit that's fully installed, has been upgraded, and it's currently working with the current onboard equipment, the legacy equipment. We are still waiting for the KUCOM unit, which has the bulk of the updates to get up there and get installed. Uh, Probably in the next couple of months it will be on board.
And when do you foresee the system being installed and ready to flip the switch and be operational?
Well, currently our timeline is to have the HRCS fully operational by late October of this year.
Okay. There, the other thing that occurred to me is that as you listen to the communications between the station and the ground, you hear sometimes people are talking at the same time on multiple channels already with just two. If you're going to add space to ground channels, you're going to add extra video channels. Are there going to be new protocols for how that's used so all the new capability isn't stepping on top of each other?
Well, we do know there's always a learning curve in when we have new technology and new things to use for. But currently, I believe our ops concept, which is to maintain our current, for example, onboard audio channels as the primary channels and using the additional ones as alternate, as to feed any overflow conversations to it, probably will ease on the transition.
Okay. Um, we started by saying that you work at the Cato console here. I bet a lot of people are wondering where Catos come from. Tell me about your own education, your professional background. How does one end up in a spot like you're in now?
Well, I mean, I received my degree for a Bachelor of Science in Electrical Engineering from the University of Texas in San Antonio. I've been a cater for about and a flight controller for about 13 years, and I believe I ended up as a cato to the fact that I had some radio frequency communications background, and I'm assuming that was part of the reasoning I became a cato.
Have you been at NASA ever since you've finished college?
Yes, right out of
Hmm.
college, 13 years.
It's take it you're enjoying yourself.
I do a lot every day.
Diego, I appreciate you taking the time to let us know about the system today. Thank you very much. Diego Serna is one of the communications and tracking officers here in the International Space Station Flight Control Room.